Hello friends, welcome back to my channel. Today's video we will try to learn about analog module FBS-2A1D. How we can use this analog module in Fatek PLC. And this is module is FBS-2A1D means this 2A means 2 analog signal input and 1D means 1 digital output signal in Fatek PLC. So let's get started. But before start this video, please like, share and subscribe my channel. This way you will be never miss my upcoming videos. First of all, I will show you in picture of my camera. If I can show you my PLC, this is the PLC and this is the analog module which I am using with this PLC. This PLC model also I will show you FBS-14 MA, and this analog module how can use this is also I will open and again refix for you. This is the main cover and how we can install this one. This just only BT. This is the analog module. As you can see, this is just only have to be fixed in on the top of the PLC, and here we can fix two screws. One is here and one is here, and after this cover can see upside this one side is analog output and one side is analog inputs. So this is fixed at the top of the PLC, and this is the connector of our analog module. This is first pin. First pin is voltage, and that here second pin is current input output. If you like to use this current output, this pins you can use, and if you like to use voltage, you can this first pin like to use. So I use this first pin for voltage output, and this last pin is GND. Here you can see this is the GND, and fix this one at upside the PLC, and this cable is connected with this Yaksawa V1000 drive, and these terminals you can use for this. Simply I will try to show you. This first one signal is AC. This is the common for minus voltages, this with this one, and this one is V1. This is voltage for plus voltage. These two terminals just you have to be used with this analog, and this two wires we have to be used. This is common, and this is the forward command. SC is common and S1 is the forward command. When you make couple joint with this common to the forward, after this will be start, and frequency we will generate from PLC. So let's go to the software. WinProLadder. WIN WinProLadder, and click it OK. And just here you have to be select only this is connect to the PLC. No need any project file open, and here you can auto check and which is communication cable connected with your PLC. That's automatically find. Click it yes, and your which program is inside your PLC, that will be backup. Already I designed this program, but I will again explain you. This is first this data register. I will edit an online. Click run. As you see D10, I move into the D4076. Because of why this is, we have to be go first here IO numbering. When you go this one and here also, this you can see FBS-2A1D is which is inside the connected with my PC. This one module, this is FBS-2A1D, and second click you can see this is the data registers of your PLC. D4072 and D4073 is the input registers and D4076 is the output registers. In PLC physical I will show you. This is the analog output. This is reads in this output register D4076, and this input modules I will talk this in next video, because video will be go to lengthy. So focus on this one only, output register, this D4076. So this register we will write it here in D10 and D406, and this will okay. And next we go to the multiply command. Why we use the multiply command? Because of we like to set the value of the drive. For example, we like to set the 50 hertz, 20 hertz, 30 hertz directly, and D5 is the multiplication with this bits. Why? Because of this I will explain you. Our drive, which is here is the drive. This drive, when we give the voltage at the command, this total bits we have to give for how much? How much? This is near around 16,000. Because of 0 to 10 volt we need, after this 0 to 10 volt completed with the 16,000 bits. How can? I will show you now. Take the status page, and here we will little stop, and here I will write D1, and here we will write the speed. For example, I will write the 10 speed, and our motor will be run at the 10 speed. So camera I will again open. This we will write the 10 speed. This is we will write here 20. What's the fault we have to be see? This is not read our, this is analog input, so we have to be again, if not this is responding look like, you have to be just stop the PLC power. I will little make the stop power, and again we have to be fix the power. Show you, this is the power. You have to be once have to be removed, after you will be again fix. Stop PLC again, and again run the PLC. see D140, but we will again this one. Again you will stop and WinProLadder open. Connect to PLC. Well, okay. And COM4. Yes, okay. Click it, okay. And here D1 we will fix one speed once, and this is we will remove first. And again fix this wire. So now our drive will start, and I will increase the 10 and click it, okay. And our motor is running at 10 speed. And if I change the 20, for example, this is now a little disturbing because of I will make it smaller, this one for you here, and later just we will take it here, and this we will put to the upside. And now we will change the speed. 10, now I will put 20 and click enter. You can see now speed is increased. If you put 30, your motor will be go at 30 speed. And also I can show you this one RPM of your motor. This is a 750 at the D20. Your RPM is showing 35, 45. See, now it's going to full. If 50 is 50 hertz, and your RPMs are now 1250. If I put 60, it will be go at 60 cycle, 1500 RPM. This is basically what we do. This is, you can see at the 16,500 are basically bits, and we multiply this one 60 cycle with the 275 equal with 16,500. If you can check with the calculator, here I will show you. See, this is the formula. This is, we are using 60 cycles, and this is how much 16,500 bits are total 0 to 10 volts, and this 60 cycles are multiplied with 60 cycles multiply with 275 equal with 16,500 total bits, and this total bits we divided by 1,500. 16,500 divided by 11 You can see the answer 1500 RPMs are now accurate. RPM also you can see, and this is your formula of your frequency. If you like to 40 this frequency, you can put the 40 and your motor will be runs at the 1000 RPM. And if you put 30, you can run your motor at the 750 RPMs. If you put 20, after frequency will be 20 and your RPMs will be reduced at 500. If you put 10, for example, your RPMs will be 250 and frequency will be 10. If you put 5, you can see 125 RPMs only running. If you put 0, also your motor will be complete stop. So this is the way of using the analog module. I hope you will be understand about this analog module, how we can use. If not understand anything, you can send me the message in comment section. I will give you feedback as soon as possible. So thanks for watching. Allah Hafiz.